So we are now basically on to the second part of the course, which is the virtualization, and we will cover it in three different modules. First, server virtualization, then storage virtualization, then network virtualization. Our goal is really to cover network virtualization, but you won't be able to understand that until we cover these two. And so today we are going to first start with server virtualization. And we will talk about as to why virtualize, what are the different concepts, what are the different products, and then we sample of them, and then a format that has been standardized. So the note, storage virtualization and network virtualization will be discussed in subsequent lectures. So this is not the lecture which is complete in that sense. So what is virtualization? Virtualization means that applications can use a resource without any concern for where it resides, what the technical interface is, how it has been implemented, which platform it uses, and how much of it is available. So we are totally unaware of what the physical resources are. Virtual view is all we know what is given to us. So if we want a 100 gigabit disk, we can get 100 gigabit disk, but we don't know whether it consists of 250 gigabit disk or just 110 gigabit disk, or it is 1000 gigabit disk. We don't know what is the real thing is, and we don't know whether it is in Germany or whether it is here, and we don't know whether it is SCSI or whether it is fiber channel, things like that, right? So as long as we don't know the real physical thing and we can use it, that is virtualization. And there are many definitions of virtualization. By the way, I found this one as the best, so I selected this one. Okay. So why do we need to virtualize? Well, we need to virtualize if you want to share something. And if you want to share, that means we have to want to break up into the pieces. Right? So we have a big building and we want to share it. We break into apartments, and that is like a virtual building. It's like a virtual home. So same thing. You have a 10 gigabit link and you really don't need that much. We can share it. 3 people can share it, with pieces of 1 2 gigabit, 1 3 gigabit, 1, whatever. Right? Virtualization. Our server, same thing. You might have a server with 18 cores, not really 18, nobody makes 18, 16 cores or 8 cores. And then, you want to share that. So that is one reason, is sharing. Second is isolation. Is that you part of a group where you really want to be protected from other tenants. So, for example, when you dial into your company, or in Vashu in this case, you don't want anybody else to see, so you want isolation. You want to be protected. They don't want anybody else to see your traffic, so that is VPN. That is another reason for virtualization, that you somehow want your own piece. Aggregation, because you don't have big enough piece, you have many small pieces, but you need a big piece, so you want to combine them. So you might take 4 switches and make one big switch, or you might take 4 links, make them one big link, or you might take 4 disks and make one big disk. Dynamics. You need to virtualize because things are moving too fast. Because either you need to have allocation very fast, or you're moving very fast, or balancing because the traffic is coming. For any reason you want to virtualize that. Ease of management. And finally, that is the most important reason, is that virtual things are very easy to manage. Physical things are very difficult to manage. And and somebody has to manage physical things too, but we will find that we just get a virtual view of something and then we manage that, and somebody else who we pay for it manages the real physical thing. And so it makes the deployment, distribution, testing very easy. Advantage of virtualization, first of all, minimizes the hardware cost. So as you will see, basically what happens is, instead of physical servers, so suppose you want to run 10 applications, you want to have web server, you want to have mail server, you want to have that server, this server. Instead of putting them all into 10 physical servers, that's what we used to do before, we put all of them on 10 virtual servers in one machine. The advantage is that now we need one machine instead of 10 machines. So CapEx has gone down. Anybody knows what is CapEx? Capital expenditure. Easily move VMs to other data centers. And for some reason you have to move one VM, you can move it easily. And you can do disaster recovery. If something happens to the main data center, you can go to some other place And then second thing is what they call follow the sun. You can follow the sun. Because in the daytime, there's a lot more activity in the United States. In the night time, you want to go to China, India, something, because there is daytime over there, night time over here. There's no activity here. Suppose you're at Facebook, there's no activity in the United States, and there's a lot more activity in Asia. So you will follow the sun. You will move your VMs to wherever the sun is. Or you may follow the moon, because you want to save energy for some reason. It's not with the users, but your load is such that you only want to go where the electricity is cheap, and generally in the night electricity is cheap, so you follow the moon. So for whatever reason you want to follow, you can move things around. Consolidate idle workloads. And so when you have 10 servers, they might be running 10% of the time, and 90% of the time they're not using the system, so you might as well put them into virtual servers, and then they can use the leftover capacity. Conserve powers, and obviously instead of 10, if you use 1, you save a lot of electricity. Easier automation. We already talked about the management part is easy, so it is lower OPEX, and OPEX is operational expenses. Simplified provisioning, management, all that thing. Scalability and flexibility. And basically you can have as many VMs, not as many, you can really do multiple VMs and then multiple operating systems and so on. So virtualization is given now. Okay. Like you saw in the Google Trends, everybody buys virtualization, everybody knows virtualization, it is everywhere. Today, you really do not do much on the real system. Believe it or not, when you go to iCloud, that is virtual. When you do Google Docs, that is virtual. So everything we do, a lot of things we do is virtual. Okay? And obviously data center is all virtual nowadays. So virtualization computing, well, it started a long time ago. So before my time, we used to have virtual memory. We still have virtual memory, but virtual memory was a favorite topic at my time. When I did my PhD in 78, everybody was doing PhD in virtual memory. How to virtualize memory. Memory was very expensive, and you wanted to do 10 kilobit, or maybe 10 kilobyte worth of memory with only 5 kilobyte of physical memory. That is the number we used to talk about, kilobytes of memory. And today we have on my computer 8 gigabytes of memory, but still we do virtual memory. Right? So that is the thing. The virtual memory was there, and then we had virtual CDs, virtual disk, and so on and so forth. And now we have virtual memory is not only level 1, we have level 1, level 2, level 3. We have multiple level of caches. So virtualization is there in the memory for a long time. Computing, we started with something called thin client. Thin client was putting a monitor on every desk, and then the real computer was in the back. Well, that was virtual desktop. Then we started virtual servers, and now the cloud, virtual data centers. So people don't want to have a full data center, they would just give it to the Amazon, right, and Google. So if these things are virtual, then networking. Now networking is the plumbing of computing. You cannot do any building without a plumbing. Can you live in a building without plumbing? Not in these days, right? In the old days maybe, but nowadays you cannot. So the idea is, so you cannot do anything without networking. If you want to do virtualization, you need networking there. And so we have had virtual networking for a long time, virtual channels, virtual LANs, and virtual private networks. But there is a lot more which has happened in the last few years. That is what we want to talk about. So let's start with server virtualization. So basically what you do is, you have two operating systems, or maybe one or two. Okay, so you have hardware, on that you run an operating system, on that you run some special program that we call hypervisor, and on that you can run many different machines, each with its own operating system. So how many of you have run virtual PC or virtual machine on your computer, laptop? Almost everybody. So this should be very clear to you that you have your Mac or Windows or Linux host operating system, and on that you run something and you get multiple of some other operating systems, right? This is called hypervisor of type 2. So it requires a host operating system and then the guest operating systems. A better way is to not have the host operating system at all. The hypervisor type 1 does everything that is required, and then the only thing you have is the guest. That is what is done in the data centers. Okay, hypervisor of type 1. And so the guest OS, for example, if you run Windows XP mode, which is kind of a standard on Windows 7, right? You get a XP license along with 7. So you can run that virtual machine. And so that is type 1, type 2. And type 1 runs on bare metals, and the names are Gen, VMware, ESXi. So these are popular type 1 hypervisors. Microsoft Virtual PC is type 2. And there are some which can do both, which can run on the operating system and which can run without the operating system. So KVM is an example. All right. However, the story does not stop there. The thing is that to run storage, you need network. To run a server, you need the storage. To run the operating system, you need the server, and so on and so forth. So there is a lot of dependencies. So you run storage on the network, server on the storage, operating system, services, desktops, applications, and users. Users run the applications. Anyway, so this is the hierarchy, and everything can be virtualized. So what is operating system? We already talked about the hardware virtualization. So we basically, the previous slide was talking about how can you virtualize your computer so that you can run another operating system on it, right? Now the question is, can the operating system, what is operating system virtualization? So operating system virtualization basically is a term where you have one operating system which is also the host as well as the guest. It is the host as well as the guest, but you have carved out the boundaries such that people in this cannot affect the people in that container. That is the virtualization part. So you have isolation. All right? And we can call them jails. So people in one jail cannot, affect the people in the other jail. And that is done, for example, when you get a Windows Server 2003 or 8, or multiple people can log in, but they will not be affecting each other. They will not be able to see each other's disk or anything. So Windows Server is an example of operating system level virtualization. And in fact, even on your computer, for example, you can download something called Sandboxy. Or Sandboxy, what it allows you to do is to create a sandbox on your computer, and you can run any program in that sandbox. It will not be able to infect your computer. So if you think that something is infected, might have a virus, you don't take a chance. You just don't run it on your computer. You run it in a sandbox, which is nothing but a container inside your operating system. So there are many programs that allow you to do that, and iCore allows you to do similar things with iCore virtual accounts. So all that is host equal to guest. That means operating system level virtualization. Desktop virtualization. Desktop virtualization is a desktop with multiple operating systems. So for example, some people here who have laptops with Mac, right, may also have Windows in that same laptop, right? Parallels, you buy parallels. And you do that, that is desktop virtualization. So you have two desktops, one for the Mac, one for the Windows, running at the same time. So Mac OS X, Windows at the same time, parallel desktop. Hypervisor type 1 is what the parallel desktop is basically. And used for testing software on multiple OS, reduces the hardware cost. Now you don't need two computers to test whether your program works on both Windows and Mac. You can just do it on one. That is desktop. Now desktop also another version called thin client. Now thin client is then when you need lots of computers, but you don't really want to buy that many computers. And this is a common case, whether you have airline reservations or whether you have a hospital or whether you have any system, you generally need hundreds of people sitting in a room doing something, and you don't want to give them each their own computer. Then you give them thin client. Thin client is basically a monitor. All right, keyboard and the mouse, along with a little thing which is very simple computer. All the work is done in the server, in the data center. All the files are saved there, but the desktop, generally the screen, is sent here to be displayed. That is called thin client. It has many, many advantages. Not only that saves you money, if somebody goes home or they want to go from this desk to that desk, It doesn't matter. They could log in on any disk. And also it's good in the sense that anyway, we'll see it one by one. So remote server provides most of the computing. All programs or data reside on the remote servers. Yeah, so they don't get lost. So that is what I was getting to, is that if one of these computers fail, nothing happens. Right? Everything is in the data center anyway. And the data center is also probably backed up. So if data center fails, you have a different backup. But here, the data is all safe. Easy maintenance and upgrade. You can upgrade any program, install anytime. You can log in on any client. Significant energy savings, obviously, you can see. Examples are Chromebooks. So Chromebooks were designed with this idea in mind. In Chromebooks, all you run is a browser, Chrome, and then everything is done in the background. But there was only one problem with those, was that you needed 3 cables, one Ethernet cable, one power cable, one USB, and all that, right? So now we came up with something called zero client, which is thinner than the thin client. In a zero client, there is only one cable, which is the power cable. You don't need the networking is by Wi-Fi, and then basically USB is also coming by Wi-Fi. So everything is wireless, and you have a monitor, keyboard, and a mouse, everything sitting there, and no cables coming in. You can put as many as you want. Just connect to the power, and you're done. You're ready. All right, thin client. So now we move up one layer up. Application virtualization. Now we said applications run on the desktop, right? So application can be virtualized by running it to run on many different operating systems and hardware. So what you do is you write applications such that they are totally independent of the hardware and the software. That is what we call Java. So Java is application virtualization in that sense. Okay. Application code, byte code, runs on many different processors because there is an interpreter which interprets the code for that hardware and that operating system. Java virtual machine. Finally, then we have service virtualization. So what is the difference between service and an application? All right. Service is very similar to the applications, but they are different. Generally, services are things which are done in the background for you, such as firewall, load balancer, proxy servers. These applications cannot run without these, but you don't see them. When you're running a web, when you go to Google, you don't know how many load balancers were on the way, how many proxy servers were on the way, how many firewalls were on the way, right? So those are the services we are talking about. They can all be virtualized. And they're implemented basically in virtual. So we have virtual appliances which are implemented in the software. For example, this load balancer might be in the software, and so it is virtual, as opposed to previously we used to have physical load balancer. So when you go to Google, first thing you need is a load balancer or a proxy server, and that is the address that you get when you go to DNS, and then it sends it to the real servers. User virtualization, and actually the correct word is user experience virtualization. So user gets the same experience regardless of what they're sitting on. So now, basically, for example, Windows 8, you could have a program running on your desktop or on your phone, it doesn't matter. Same interface, same thing happens. You could be running here and go there. Actually, it's not just Windows 8, but even on many other systems, you could switch between the laptop or maybe tablet, a phone, and laptop. So that is basically user gets the same experience regardless of what the physical hardware is. All right, and so the applications and settings are stored in a central data center. So basically, they are not stored on the device. So that's why you can switch the device. You could be working on the laptop in a minute. You would go back to your tablet, and it will start from where you were before. Okay, Microsoft has something called UEV, User Experience Virtualization, which allows you to do that. Yeah, so basically we saw that how you can virtualize at any layer or every layer actually. Next thing is there are some other concepts related to virtualization which are used, and you should know the difference. For example, hardware emulation. I mean, these four concepts which are on this slide: hardware emulation, assisted virtualization, parallel virtual machines, and parallel virtualization. I'm going to explain them one by one. So hardware emulation simply means that you want to somehow simulate or emulate, is the right word actually, hardware on the hardware. So you have a x86 processor, but you really want a Spark. Or you have a Spark and you need x86. So you can run some software which does that for you. Okay, so I think there is a cost to the hypervisor. Yeah. Let me just tell you, hypervisor cost is nothing compared to the Windows license. I mean, so that gives you some idea. In fact, people don't charge for hypervisor anymore. They charge just for the managing the hypervisor. So you will see that in a minute we are going to talk about a few products. So hypervisors are almost for free. And software in general is for free. What is happening is we are going more and more open source software. So most people, when they have this demand for lots of these, they really used open source Linux, or Unix or something, so that, I mean, the people who are using the computer, they just notice the web browser. They don't know what web browser is running on. You see what I mean? So really, open source is one thing which is happening, and second thing is the hypervisor. So hypervisor are also kind of open source. We talk about Zen and things like that. Those are all open source. Okay, so the idea is if you didn't have hypervisor, your system will run much faster. That is true, but at the same time, there is a cost, right? I mean, you got two computers out of one. You got a Mac and a Windows on the same laptop, so you save $2,000. So did you pay something? Yeah, now the things will run a little bit slow, right? And so it's not that there is no cost. Yes, there is a performance cost to it. And those of us who have installed VM on our laptop, we know that we use VM only in the extreme cases. So for example, I have VM, but there are particular jobs that will not run on my original laptop. I need to run them, so I go to VM. Right? And I can afford the cost, I afford the performance degradation in those instances. And actually the performance of VMs is also improving. I mean, I remember previously VMs were so slow that you will never go there. Now, VMs are becoming faster and faster. And why? Because of the next thing which is coming up. So we go to the hardware assisted. So reason virtualization is fast nowadays is because when everybody started doing virtualization, Intel had to think about it and see how we can make it better so that it doesn't feel like it's slower. Right? So there are several things in the hardware, in the processor design itself, which allow you to switch from one VM to the next VM. I mean, for the hypervisor to switch from one VM to the next VM and have them all believe that they are running on the bare metal. And those things are called Intel VT or AMD V. AMD has designed a similar thing called AMD V, and they help virtualization. If you have those features in your computer, laptop, which you might, then you will find that your virtual machines run much faster. All right? And hypervisors can use these instructions to improve the performance. So there are some special instructions which your processor, if they have it, then the hypervisor will run faster. And KVM, Hyper-V, VC, all of these use these features.